Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to be creating this mechanical iris model inside of Fusion. Now, this came in as a question on the Discord channel from Troy, who is at Heart Made Woodworking. If you want to check out the woodworking that he does, you can go to the description of this video. There's a link there. He makes some really amazing stuff, and this is part of something that he's working on now. So what I want to do in this video is I want to talk a little bit about how to set up this model. We're going to go through things like bodies and components. We'll learn a bit more about joints, including things like the tangent relationship, and we'll figure out how we can model this. Full disclosure, there are many different types of these iris mechanisms. This one is looking at these petals that sort of nest to each other. Some of them, like camera irises inside of lenses, will actually have these leaves or petals that overlap. And there are other kinds that have 4-bar linkages and all kinds of different things in it. I picked this one because this is probably the easiest to model and understand. That way we're not so bogged down on having to worry about things like math and figuring out all these sort of arcs and motions. So we're going to make this one here, and if we want to in the future, maybe we'll make another one that's a bit more complex. But let's go ahead and get started with this. So we're going to begin a new design. I'm working in the metric unit system. If you want to work in inches, perfectly fine. It's not going to make a difference to this design. Just adjust your values accordingly. We're going to get started with a new sketch. And this is a part of the design that I get a lot of questions on. People ask kind of about workflow. Do you make all bodies and convert to components? Do you make all components early? And kind of it depends. And I say it depends because it does. Now, there are different CAD programs. If we're using SolidWorks, for example, then if we wanted to do all bodies, we would do a master model inside of a single part file, and then we would save those bodies into their own files and into an assembly. That workflow is something that I've done for many years, and I actually enjoy it in Fusion as well, making the bodies and then converting them to components. But there is, of course, a nuance there. If the components are going to be extremely detailed, and what I mean by that is if the features and sketches take up the entire bottom of the timeline and you end up having to scroll back and forth quite a bit, or if there's a lot of interdependencies, those are two main things that would drive my decision one way or the other. For the mechanical iris here, the geometry is simple, the number of features is fairly simple, so we don't need to go into making components early on. Is it going to affect what we do here? Not at all. You can certainly start out making components. I am going to begin by making bodies just because of the way that this design works. I think it's a little bit easier. So we're going to begin by creating a center diameter circle, and I'm going to create a second one, and we're actually going to hit escape, and then we're going to add some dimensions. We're going to start by giving the inside one 100 millimeters, and the outside one is going to have a distance between the two. I don't know what the numbers are that we need, but these wedge pieces or these blades need to be completely hidden inside of here. So you can kind of plan and figure out how much space you need based on the fact that we've got essentially 50 millimeters here, and we need to completely hide that over in the side here. Now it's not one-to-one because we can't just take this distance of 35. If we were to have a triangle here, and what I'm going to do is I'm just going to make one here. I'm going to put a vertical line, hit escape, and make this construction. Now there are shortcut keys, X on the keyboard for that. Let's go ahead and select the left line, the right line, and the center. Select the center last and use symmetry. This allows me to kind of move these around. And then we're going to give these a dimension based on the number of petals or leaves that we want. So 360 degrees divided by the number that you want. I'm going to use 8 for this example. We could use more or less. That really depends on what you're doing. 8's a good number. The more you add, the more joints you'll have to add to make this work mechanically. The fewer you add, the simpler it becomes. So if you want a sort of an easier one, then just reduce that number. So now we've got this wedge shape, and what I'm going to do is I'm going to select these two lines and hit M on the keyboard, which is move copy. I'm going to create a copy, and I'm just going to drag this out to the left. All right, so this is the direction that this piece is going to be moving. And what we need to think about is how far we're moving it. In this case, it looks like 55 millimeters will completely hide it. and whether or not we can completely hide everything inside of that shape. We're not going to keep this, so I will be deleting it, but just keep in mind that what we're going to be doing is creating this wedge piece that's going to move off to the side. Now, if I add another arc from here to, let's say, there, and I'll make these two concentric, basically what that's going to do is it's going to give me that little wedge piece. I'm going to undo this. I just wanted to do that as sort of a visual representation of what we're doing. Because we're only going to be working in this sort of upper section here, these two quadrants, I'm going to zoom in a bit. So now this is our wedge piece, and it's going to be moving off to the left. To make that happen, we're going to add a slot. So create slot center to center. We're going to go from this vertical line here and just off to the left. And I'm going to give it a value of 5 millimeters. It's going to be big enough for what we need. There's going to have to be a pin that fits between this wedge piece into that slot. Now, there are a couple of other important things that we need to think about here. I'm going to add a couple more circles, and hopefully this will be clear. From the origin to this point, and then the origin to this point, hit escape, and convert both of these to construction. Again, X on the keyboard, or click line type construction over here. Now, what I mean here is that this diameter is going to affect the length of the slot. It's going to affect how far that piece moves in and out. And these numbers are important because when we make our secondary slot for the top ring that's going to move, that secondary slot is going to go from this position and it's going to go vertically until it hits this circle. So that's how we get our two dimensions. This left-right one is going to dictate how far that wedge moves left and right. And the vertical one is going to spin and it's going to dictate the pin moving along this slot. So we're going to use one pin location to help drive this, and then the sort of intersection between all of the other pieces to make this work. So what we can do is we can define the diameters of these, again, D on the keyboard for dimension, and I'm going to say 140 millimeters, and let's go to this one and say 160. I don't know if these numbers are going to work. We can always come back and change them. And the last thing that I want to do here is add a circle. And we want to make sure that we're centered. So we're going to go at the center point here. We're not going to make it exactly the same. I'm going to make it 4.5 millimeters. If you were to 3D print this, or if you were to try to manufacture it, then obviously you need to think about the tolerances that you have available to you. If you're using a 3D printer, it's generally plus or minus 0.1 to 0.2 millimeters. My printer actually prints undersized a little bit, which can be difficult if you're trying to get things like hole sizes for bolts and pins, but those are the general numbers that we have to work with. So now that we have this, we also need to think about the bit that we're going to cut away from the outside of this wedge piece. That bit, we're not really sure. Again, moving it off to the side 50 millimeters gave us a good idea of what that would look like. But I'm going to add a few more dimensions. I want to see what this travel is, keeping in mind that this is a driven dimension. Basically, we can't add this dimension. It's already defined. And I also want to know what the outside diameter is as well. Once again, it's driven. So now we know 170 on the outside and 38.73 is the distance. So what that means to me is that if I take an arc and I go from here, it's probably not going to come up to that corner, but somewhere around here. What we want is this radius and this radius to match so we can make them equal. I'm going to hit escape, and then we're going to drag it down. And then what we need to do is we need to figure out the distance from this origin to that point. So if I select this point and select the origin and make them horizontal, and then I use D on the keyboard to figure this out, this value should be approximately the same as this value, 38.73. What we could do is we could click on it and set those equal. Even though this one is driven, that is going to automatically update that little wedge piece. Now we'll have to do some testing and figure out if it actually will work in reality, but this is where these numbers are coming from. Now, I know the sketch is a lot, but for me, at least as I'm designing things like this, it's easier to put a lot of this in one sketch because we can move and copy bodies around or copy these sketch lines around and give us a good idea. We'll have to come back and we'll make the ring, the sliding ring, in a separate sketch, but we're going to start by sort of shift selecting everything and then we're going to extrude it. You can use E on the keyboard. I'm going to pull this forward. Let's go ahead and let's just do, I don't know, -3 millimeters. Bring the sketch back, and now we're going to cut the slot in it. The reason that I like to do it this way is because it makes patterning the feature a bit easier. You don't have to do it this way. You could pattern the faces and it would work just fine if you wanted to just do that single extrude. But I like to keep these things a bit separated, even though it adds more features to the timeline. We're going to do through all, say OK, and now we can pattern that. So we're going to do a circular pattern of features. We're going to select that extrude cut feature. We're going to pattern it about the y-axis, so we can either select that or a cylindrical edge. And then we're going to add the number of pieces we need. Again, depending on how you define that wedge piece, whether it's 6 or 8, that's how we're going to get those numbers. So if we go back to the sketch, right-click and show dimensions, this dimension here was 360 divided by 8. That means that we're going to have 8 of these wedge pieces. So that's why I chose to pattern this 8 times. The next thing that we're going to do is we're going to extrude that wedge piece. So again, E on the keyboard. I'm going to hold down Control, and we want to extrude all of that. I'm going to make this go the opposite direction. Keep in mind, when we're designing this model, if you were to actually make this, there are more pieces that you would need to do, right? So we're looking at the kinematics, the mechanical motion of this part. We're not putting all the little details together to actually make it ready to be printed. If you want to carry on and do that yourself, you certainly can. It's not much more than we're going to do, but it will just make the video quite a bit longer. So we're going to make this a new body. We're going to hit E again for extrude. Also, you can use the right-click marking menu, and the 12 o'clock position is repeat. So I like doing that, especially if I'm doing something over and over again that doesn't have a shortcut. You just hold the left mouse button down and drag up. That's a quick way to get back to that extrude feature. So this pin is going to come up, and I'm going to make it come up 8 millimeters. That'll allow it to go into the next ring. And because it's undersized, it's not going to try to join it to this body. But one thing that I would caution you in Fusion is if you're going to be joining features together, then make sure that you hide any of the other bodies you don't want to connect it to. So we're going to say OK there. And we'll bring that body back and hide the sketch. And at this point, I want to add a couple of fillets. Maybe we'll get this edge, and that one. And just round them off. They don't need to be extreme. We're just going to kind of cut the edges a bit. And now we want to kind of test it out. So this body here is going to be stationary. It actually does not need to be a component. You can convert it to a component and pin it or ground it. They changed the name of ground to pin now. But this one definitely has to be a component. So we're going to just start by converting that one to a component. And we'll say OK. And then we're going to add an as-built joint. So we're going to use a slider joint between this and along this edge here. Currently, it's completely open. There are no motion limits, and I'm going to leave it like that for now because I basically want to evaluate what's happening here. So because we use the numbers, we can see as we pull this all the way to the outside that it is matching the outside shape. That's perfect. That's exactly what we wanted. However, it's not hidden inside of this inside diameter. Because of that, what that tells me is that we need to make some adjustments to this sketch. Keep in mind that this 35 millimeters is an offset distance. It's a distance between the inside diameter and the outside diameter. The outside works great how it is. So anything I do to change the inside diameter, this 100 millimeters, I want to add back to this so that it still equals 170. Even if it doesn't, we can use these reference numbers to make things equal. So what I'm going to do is I'm going to change this to 90 millimeters. And now you can see the pin is kind of just hanging out on the outside of this, which means that if I try to move it, you can see the slot is now sort of outside of here. So we don't want to do that. We want to make sure that we repair those things. So I'm going to add 10 to this and make that 45 to make it a bit bigger. And again, part of the reason for that is now if we drag this to the left, you can see that we're getting closer to hiding this. Again, it becomes sort of this tricky game. We can go further now with these numbers until this position, and it's really hard to see, but if we double click on the joint here, it tells us that we've moved 47.71 millimeters. So that is going to get us really close to exiting, going about 48 millimeters. So what we're going to do is revert our position, bring back that sketch. Remember, right now it's sitting at 38. And the reason it looks like this is because that new component is making everything look, changing the opacity. So we want to go about 48 millimeters, which means that this diameter, this outside diameter of 160, needs to increase. So if we make this 170, it now takes us to a little bit over 48 millimeters. So now if we take this wedge and drag it to the side, it looks like it's just about completely hidden. You can see there's a little bit more in there. What we could do is we could shave off the outside a bit more, but this is now, we're now at a position where we've got good numbers. So now I can go back to the joint, I can edit the joint, and I can say min and max. Now, when we have min and max values, we have to look at the arrow direction. It's pointing to the right. So that means I'm going to have minus 48 millimeters, and it's going to stop in those positions. If the arrow is pointing the other way, then the min would be 0 and the max would be positive 48. So you just kind of have to look at the arrow direction, and that all depends on the selection when you add that joint. So everything's looking pretty good so far. And what we could do is now we can pattern this component. So what I'm going to do is go to my pattern, circular pattern of the component, about a cylindrical axis, or we can select Y. Fusion doesn't really care if you make changes to the geometry because everything we do is based on a timeline. That's not true in other CAD programs. If we were to do this in SolidWorks or Inventor, for example, the assemblies don't have that sort of history. So it would have a problem if we went back and say added a chamfer to that edge. So we're going to go to 8. And now we've got all 8 of these here. The problem we now have is we have to add this joint to all of them. So to do that, we're going to go to Assemble, As Built Joint, because everything is in the correct position now. And we're going to just start plugging them off. So this one to this one, and then select that midpoint. And right click into the right position at 3 o'clock and OK. And then again, 12 o'clock position. And we're just going to work our way through. And you can see it's going the wrong direction. And that's because the selection for the snap, the arrow is pointing in the wrong direction. So to the right, 3 o'clock position. Then we're going to go here, and we're going to make sure the arrow is pointing the right way. If it's not, just reselect it. It can be a little bit tricky if you don't rotate it. So sometimes it's good to just rotate it. And again, that right-click marking menu, just repeat the joints. We're going to go from here to here. So right-click, repeat as-built joint. This one to here. Select your slider position, and just work your way around. Once you get comfortable with using the marking menu, it really does speed things up quite a bit. And we just need to work our way through. And the last one here. Now, the next thing you're probably wondering is, how do we actually get them all to move together? Because right now, they all move like they should. I did not add any limits to the rest of them, and that was for a specific reason. But now the next thing that we need to do is we need to add what's called a motion link. Now, something I do want to caution you about here is look at the direction of each of these joints. So this arrow is going to the right, that one's going to the right, that one essentially is going to the right. This one switches directions. So you can see these ones over here switch directions. The reason that's important is because when we add our motion link, which a motion link connects 2 joints together, these two, clicking this one and this one, these two go the same direction. And that means that the joint limit on that first one is going to limit the second one. So I don't have to go through the process of tweaking that joint limit. And that the reason that's important is because if we make dimension changes to any of this, we don't want to have to edit 8 joints to edit that motion link. So we're going to do a repeat, and we're just going to work our way around. And as long as the arrows are facing the same direction, it's fine. Where you start to get into trouble is when they face the wrong direction. So if the preview animates improperly, you want to click reverse and make sure they're all going the same direction. Again, right click, marking menu. We're going to go from here to here. These two arrows are pointing the same way, so it's fine. And this one is pointing the same way, so it's fine. These two are opposite, so we will have to reverse the direction. And then we've got the last one here. These two are the same, so everything should animate properly. So at this point, we have the mechanism to where we can slide this pin and we can open up everything, and you can see that it completely hides or almost completely hides, and then it comes all the way back. So that's the bulk of how the motion works. But obviously in reality, we don't have something like a motion link. What's going to end up happening in reality is that these pieces can just move on their own. They're not constrained. They can rotate and they can sort of move on their own. So the rotation is a little bit of a problem. And the way that we would fix that is by adding a secondary slot. So having two slots, or instead of making this round, making it square. Making it square would ensure that it doesn't rotate as it slides along the slot. But for the purposes of our video, again, because we're not going into the details to physically make this, this is going to represent the mechanical motion. The next thing that we need is another component that we can rotate. Before I get into that, what I want to do is create a new sketch on this face here. I'm going to use a circle tool, and I'm just going to add, let's say something at 110 millimeters. And I'm going to extrude this. So E on the keyboard, and we're going to pull a little ring up. This could go the other direction as well, depending on how you want to sort of orient this. When we click join, we do want to make sure that everything still works. This, remember, is just a body. We didn't make it a component, and everything does still appear to work. So let's go back to this front view. So now let's create a new component. So this new component is going to be the ring that spins. So I'm just going to call this spin ring. Pretty simple. So the spin ring is going to be based off of this face. So I'm going to click on the face, right click, and create a sketch. However, everything that's here, I want to make construction. I don't want to use any of it, except I want to have those references here. So this ring is going to be here. I'm going to go ahead and take that one back. This outside one, we can keep the same if we want. And we want to create a slot that goes from this position to that vertical position. So we need to bring back sketch one, and I'm going to select this line here, and I'm going to project it. You can use P on the keyboard, or you can go into our create menu and project it. Again, construction. It's already, so when we click on it, we have to hide sketch one, and then we can turn this one into construction. If you ever run into that, if you have problems making the right selection, you can always hold down the left mouse button, and that's going to bring up this selection, which will allow you to pick which sketch arc you want. And then there's also this parent-child menu here. This basically tells you that it belongs to sketch one here. So we're going to go to create, slot, center to center, go from this position up to this position, and we're going to give it a 5 millimeter dimension and finish our sketch. So this time I'm going to do an extrude. I'm going to leave that hole there. And the reason for this is because I'll show you how we can do a pattern with the, we're going to do a pattern just with the face instead of the feature. So that looks okay. This is going to be a new body inside of our component. And then we're going to create a circular pattern based on faces. And we'll select these inside faces here. And just make sure that we're grabbing everything, all 4 of them. And that's going to be about the y-axis or a circular edge. And of course, it's 8. And there we go. The next thing that we want to do is make sure that we've got an appropriate joint. So this one's going to have a revolute joint because it's going to rotate. So we'll go to as-built joint again because it's in the right location. Revolute between this and the base. And it's going to rotate about that center part. You can see that selection is not correct. So we want to make sure that it's revolving about the y-axis. And we'll say OK. Now here is where things get a little trickier. Now, you would probably want to do a slot joint for this pin and this body here. Now the problem with that is while that works in reality, Fusion does have some difficulty making that work. So we've got two main ways that we can get around that. We can either go to turn on our contact sets, and what that's going to do is it's going to look at all the solid body contacts between this pin, or really this sort of wedge here, and this body here. Now that works fine, but it does require some computing overhead. The probably easiest way to do this is to use tangent relationships. And basically what we're going to do is we're going to say that this face here maintains tangency with this. Because the circular part of that, the semicircle here, is an extension of that edge, this will be just fine. We could add additional faces if we needed to, but this is going to work for us. So if we did everything right, I should be able to turn this and the iris will open. So let's give it a shot. So as I pull it to the left, it's opening the iris and it's going to stop right there. Now, even though I didn't have, basically the only thing that's controlling it stopping is the limit on this one slider joint. Everything else is controlled by that one slider joint. So what you can see is the tangent relationship is keeping the pin on the edge of that face, and depending on how we move it, it might actually jump to the other side. So you can see once it gets over here, it carried on because that slot has tangency. So it might jump back and forth, but again, we're talking about 4.5 to 5 millimeters, so 4.5 pin, 5 millimeter slot. So let's do something a little bit more here. On the slip ring or the spin ring, I'm going to right click, go to opacity control and change it to 30%. I'm also going to go and turn on inspect and component colors. This looks a bit crazy. So all of these are the same color because they're copies or patterns of that same component. But everything else, the green and the orange, which are honestly a little hard to look at, I'm going to go right click up here and I'm going to cycle that color and get something. It's not much better, but it's okay. But basically what we want to do is we want to look at what's going on here. So this other body here, right click, opacity control, I'm going to turn that down as well. So the pin that we have on each of these sort of triangle wedge pieces, that pin is fixed into two separate slots. The left-right slot we have going from this inside diameter to this outside diameter. So as we rotate this around, it's traveling along that. The vertical slot that we created also travels along that inside to outside diameter, except for it's doing it vertically. So one's going horizontally, which is controlling the motion of the wedge piece, and one's going vertically, which is giving us that other limit here. So this, mechanically speaking, again, was probably the most simple version of this mechanical iris. The other types require a little bit more math knowledge and a little bit more finesse. But overall, that is the process to create this mechanical iris. Now, there are more things that you can do. I've already mentioned that this, as it stands, is not ready to be manufactured. But if you were going to try to make a 3D printed version of this, what I would suggest is that the spin ring here that we have, that goes on the back side to hold in the iris, and then you simply extend the pin from this side through to the other side, and it'll still work just the same. These slots also don't have to go all the way through. The slots can be hidden so that you don't actually see any of that. But mechanically speaking, you would still need to spin the outside ring in order to get that motion. So if you have any questions on this specific topic, then please leave a comment in the video. If you like what you see here, consider subscribing to the channel. We do cover a lot, including Fusion and plasticity and Blender and SolidWorks, as well as programming knowledge inside of Arduino. We've got a couple of other projects coming up as well. So we're trying to get to everything that we possibly can, but we need to know what you guys want to see in order to make the video that you want to watch. So if you have any information on what you want to see, leave us a comment and I'll add it to the list. And as always, thanks for watching. We'll see you in the next one.